What I want to talk about today is part of a larger study that I've got underway on what is really kind of a small issue in a lot of ways, but one is kind of critical, and that is how do you give electrical power to a spacecraft that's going some other place? And there's a variety of ways to do it, and in the case that I want to talk about today, these are nuclear power sources, and how does the public react to those? There's a variety of sources, and most of us are familiar with spacecraft with big solar arrays on them that are powered by the sun's energy turned into electrical power. That works very well inside of the area from about Mars toward the sun, not so much beyond that. And the longevity of that is pretty good. The amount of power that's created through that process is pretty good. And you can see that in that little yellow triangle right in the middle. There's also chemical systems that can be used to power spacecraft. They deliver a fair amount of electrical power, but they do it for a very short period of time. So batteries or fuel cells come into that category. Then there's a variety of other things over on the right-hand side of that particular slide that's nuclear of some type or another. There are passive systems that offer longevity of service of decades, and those have been used routinely for outer planetary exploration. And so we've already mentioned Voyager today. That was powered by a nuclear system. There are things that are more powerful than a passive system, up to and including nuclear reactors that are flown on spacecraft, but they create their own specific problems and are not used very often. Now, this is basically RTG 101. For those of you who don't know that term, radioisotope thermoelectric generator. It's a pretty simple system in a lot of ways. In the United States, they build these in hardened shells with plutonium-238. That has a half-life of 76 years. It then is attached to a thermocouple, and the heat that is produced by the plutonium is used to create electrical power. Works pretty well. Virtually all the out-of-planetary probes, even those that have gone to Mars, are powered by these types of systems. Here's a standard version of it that has been flown many, many times and tends to work fairly well. There's a lot, since thermocouples in this particular system are not very efficient, the majority of the heat is not turned into electrical power, only about 10%. The rest of it has to be dissipated. You can see those fans that are kind of off to the sides of this thing, which are essentially means of conducting that heat away from the spacecraft and out into space. That's the basic RTG. This concept became very popular in the 1950s. And the work on it really started in the 1940s with the Atoms for Peace program and the efforts to try to figure out ways to use atomic power or use atomics that have been developed for destructive purposes in a positive way. The RTG was one of these that everybody thought immediately had application. It had application both here on Earth and for powering spacecraft. For instance, and it could be used in the context of drift stations that would be located in the Arctic during the Cold War, where you could power the systems that are there and not have somebody there all the time and not worry about it except to collect data periodically. That's certainly one approach. Dwight Eisenhower made it a bit of a splash with it. He had one displayed in the Oval Office in 1959. And you can see him on the far left and a bunch of other muckety-mucks from Washington standing next to him looking at this small thing on the desk in the Oval Office. So it became a very public sort of activity. And the military specifically thought of it as a very useful power source for spacecraft that were being developed for all kinds of purposes in the Cold War environment. Navigation satellites, weather satellites, communication satellites, spy satellites, and so on and so forth. And it got adopted very early on by the Navy. Beginning in 1961, the transit navigation satellites that they built had RTGs associated with the power for those. solar arrays they deemed were not sufficiently advanced for powering these systems at that point in time, so they put these nukes on them. They didn't bother to tell a whole lot of people that they put nukes on them. And the way in which they handled those nukes was not necessarily one that would pass muster. For instance, Transit 4A, there was a lot of controversy inside the federal government about its launch in 1961. The Kennedy administration, there were a number of people there who said, this is a really bad idea. What if something fails? We blow up rockets on a daily basis. We can nuke parts of California or the launch complex down at Cape Canaveral or any number of other places. There were folks inside what became the Department of Energy, the Nuclear Regulatory Commission, the Atomic Energy Commission, who said, oh no, we can do this, we can build these things, they're completely safe. And it really went back and forth for a while until only 3 days before the launch. Glenn Seaborg, who was the director of the atomic programs, had a private dinner with Kennedy in which he convinced him that it was okay to launch these things. And at that point, literally, the folks at the Atomic Energy Commission put the RTG in the trunk of a private vehicle, drove it from Washington, D.C. to the Applied Research Laboratory, which is up near Laurel, Maryland. They did a fit check there, and then they put it in another private vehicle, the one that was owned by John DeSoulis, and some of you who are associated with the Air and Space Museum may know John, who's one of our docents there now, who was a nuclear engineer for many years, until he finally retired, and physically drove it to the Martin Corporation in Baltimore, where they boxed it up and shipped it down to what became the Kennedy Space Center, Cape Canaveral at that time, for launch just a few days later. They flew it. It got some publicity at the time, not terribly negative publicity overall. And in fact, when you look at the newspaper accounts, and by the way, for anyone who wishes to read a full paper, I have about 30 pages worth. Just let me know, and I'll be glad to give it to you. But I'm not going to quote all this stuff, except to say, give you a general gist of it, that oh my goodness, this is a great new opportunity. We pioneered the use of atomics in all kinds of arenas, and now we're doing it for things that are peaceful and fun-loving and so on and so forth. Never mind that it was a navigational satellite to enable submarines, ballistic missile submarines, to be able to know what they're targeting and where they were located on the Earth, so that they could, in the end, nuke the Soviet Union. They launched several of these. They flew without a lot of difficulties, although there were accidents. Most famously, the Nimbus B-1 accident in 1968, in which a rocket was lost during launch, and the destruct sequence had to be executed because it was headed for Los Angeles. And they blew it up over the ocean, and literally the spacecraft spun in. The casing for the RTG went to the bottom of the ocean, about 300 feet deep, and was later recovered. The photograph that you see is a picture of the RTG as the divers are going down to find it in 1968. There's been a variety of other things like this as well that have happened over the years. This is the only one that was recovered. The rest of them ended up in the drink someplace. Some of them in the deepest parts of the ocean, as in the case of the Apollo 13 lunar module, which was used as a lifeboat. Anybody who's seen that movie from a few years ago, and the Apollo 13 accident that took place, and the lunar module was powered, had an RTG aboard. And it was lost in the Marianas Trench, so it's fairly deep and probably not a problem, except for sea creatures down there. NASA, of course, was not in the forefront of developing this technology. It was interested in it, and all through the 1960s watched what was taking place, but did not participate in it except in the context of R&D activities until the outer planetary missions began in the 1970s. And The Pioneer 10 and 11 spacecraft that went to basically on windshield tour of Jupiter and Saturn were powered by the RTGs. The Voyagers 1 and 2 that Ray's already talked about that had their little gold record on them was also powered by RTGs, and all of the missions since that time that have gone out beyond Mars and some that have gone to Mars have been used for these purposes. This is a schematic that I got from NASA, just taking credit for all of these missions